Yay! All right. I see a lot of Macs. I'm surprised by that, actually. Okay. So good afternoon. I hope you guys are enjoying the conference. Has it been a good conference for you guys so far? Awesome. Yeah? Good. All right. So when they talked about doing call for papers, I had already been kind of going, when's call for papers? When's call for papers? Because I really had a couple things I wanted to talk about. And one of them had been IPv6, because it had been a topic that several of our clients had been curious about. So being a traveling instructor, I get to talk about different topics. And every now and then a client goes, we really want you to talk about this particular feature. And it just happened to be IPv6. So, little thank you note, GuruLabs for giving me the time off. They are my employer. It's a fun place to work. My coworker Matthew, who took a class for me this week, so I could actually get the time off. And to Stuart. I don't know how many of you guys know Stuart, but Stuart is the one that when we had a client that said, we want to learn about IPv6, it's part of why you're coming out here. And I went, you sure you want me to go? Because I know nothing about IPv6. He sat down with me and tried to teach me. He did his best. It took a little while for some of the concepts to sink in. Okay. So let's start with the obvious question. Why are we moving to IPv6? How many of you guys have looked at moving to IPv6 in the past? I'm just kind of curious. So some of you guys have. How many of you guys have heard the great news that we're running out of IPv4 addresses? Yeah. So that's been all over the place. How many of you guys think we could actually live in IPv4 for a little bit longer? Yeah, we could. Absolutely, we could. The problem is it's not going to be a long-term solution. And really, quite frankly, the reason why we've gotten to this stage is because of natting. We've been conservative about address allocation. We've reclaimed some addresses, but more than anything, it's been natting. That's not really what we wanted with an internet, right? We wanted to tie everything together. We wanted full two-way communication. IPv6 is going to allow that because we're going to have larger address space. IPv6 should give us better network performance, actually. It should be easier for routers to handle the packets. We have a fixed size, so they don't have to sit there and try to determine how long a packet actually is. The routers aren't allowed to fragment packets. They send that back to the source. So the routers don't have to be smart enough to go, how do I break this apart, retransmit it, how do I reassemble it? It doesn't have to worry about any of that. It tells the source, my MTU is this size, here's your packet back. And then the client is responsible for fragmentation. All right, World IPv6 Day. Right, so June 6th this year. How many of you guys played around with or heard about World IPv6 last year? Yeah, a couple people. A lot of large corporations went, so this IPv6 thing sounds kind of important. What's going to break when we turn it on? Well, we should probably test this. So they turned it on, and they took notes, and they ran it for a day. And they decided, well, really, most things have worked. By the way, I did put a capital P in there. You're going to see this. Autocorrects. So this time around, they went, all right, we've learned everything we need to know. We're going to turn it on. We're going to leave it on. So this coming 6th of June is the big day. You're going to be able to access most of your sites. By the way, does anyone else think there's a hidden joke here? There's 2 6s into 12. That gives you 4 6s altogether. When we talk about finding an IPv6 address in the DNS system, the resource record is quad A. 4 times the space, 4 times the A's. So this actually gives you 4 6s. So I think there's a little bit of a joke there. It's not as good as May the 4th be with you, but it's there. And finally, the last reason is peer pressure. Everyone else is going to be moving over to it. So eventually, we're going to hit a point where if you want connectivity, you're going to use IPv6. So what can break if you go to IPv6? Because that's probably a big consideration for you. Well, you may have older equipment, older software or specialized software that does some really bad things. One is it may be hard-coded for IPv4. That's not a good thing, right? You may have specialty items, like my squeeze box, that just didn't put in support at all. It's really sad. I checked it. It's like the one device I know on my home network is not going to make the transition. And for it, I'm going to have to run a dual stack. The good news is, actually, most of your older components will actually still work if you're thinking about hubs and switches. They'll still pass the Ethernet frames. You can run dual infrastructures. It was a design requirement to allow you to actually run both infrastructures without interference. So if you want to continue to run your IPv4 network, you absolutely can do that. There's no problem there.
When you run a dual network, what does your DNS resolver say in Ubuntu query first? Does it query first for quad A or single A?
I'm not sure about Ubuntu. However, my experience in Fedora has been that I get IPv4.
Okay. Yeah. Is that configurable in most operating systems?
You know, that's not an option that I know of.
Okay.
So
that has to be enabled as well. That has to be changed. The user land has to be changed as well to be configurable for that.
Yeah, probably does. What I've seen using like the host command and so forth, it actually returns both A and quad A.
Okay.
So as far as I know, it's really up to the application. That's a good question. I hadn't thought about that question, but that's an excellent question. All right. Where are we seeing IPv6 being deployed currently? We developed this thing back in the 90s. Some places started deploying it in the 90s. It really just was here that we kind of went, yeah, that's kind of cool, and we'll get around to it eventually. Sometime down the road. Mainly it's been Asia. Why has Asia deployed this? They're huge, absolutely. And the other factor there is, who got the bulk of IPv4 addresses? We absolutely did. Yep, so we're sitting here, we got 70% of the IPv4 addresses, and they're over there with this little tiny sliver, and they're like, we got this huge population in places like Japan, very technologically advanced. They're like, how's this going to work? So IPv6 comes around, they're like, oh, we love this thing. We're going to get corporations in on this. We're going to get governmental participation, commissions, the whole bit. And that's what they did. The other place that you're going to really see this, how many of you guys heard about IPv6 in China during the Olympics? No? One of the projects that China undertook was creating a next generation internet. It's completely IPv6. During the Beijing Olympics, they set up a lot of security cameras. It's a very high profile event. They were IP cameras and they were all IPv6. So they've got some pretty good experience going on over there. So it's definitely being deployed. Again, we're just kind of late to the party. All right. So the IPv6 space is a really, really, really big space. And if you want a comparison, Aaron has one. Did you know you got referenced in Wikipedia?
Yes, my server's constantly slammed as a result. So.
Nice. You know, if you move it over to IPv6, it'll lower the traffic. It's worth pointing out, by the way, on that note, Google says 1% of their traffic right now is IPv6. Yeah, so how big is this space? IPv4 used a 32-bit value, so you got just about 4 billion combinations. IPv6 uses a 128-bit value. I'm not even going to try and tell you what that number is. It's a really, 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 really big value. In fact, how big is it actually in real life? Everyone else seems to have this size thing. Aaron's got an excellent one. I guess I have to kind of do that as well. So thinking about this, about a month or two out, I went, you know, what would be really cool is to talk about the aliens coming. And we could go ahead and take these little LED lights, give each one an IPv6 address, and I wonder how big that would be. And I actually did create an image, and I didn't actually put it up. I figured we could have a picture of the Earth, and it could have a sign, and it could say welcome, and it could say, please don't invade us, and then it could say, please don't kill us, please don't eat us, because frankly, that and zombies, that's a problem. And then it could finally say, have you tried Mars? And the humor there for me was the fact that we could actually still have extras and go over to Mars, and we could have clothes for remodeling. And I thought, okay, that'd be kind of cute. But you know what? It turns out we would still have extras. In fact, how many of you guys have ever actually played around with this number at all? Other than Aaron. I know Aaron has. Okay. So let's actually do that for a moment here. So I'm going to just go ahead and toss this thing up. Yeah. Oh, that's the other thing that I'm not keen on there. Okay. So there we go. So we're going to talk about two 128th power. There's our number, big old number. And let's go ahead and say that we do this for an LED. LEDs typically are between 3 millimeters and 5 millimeters in size. So we're just going to do a very simple multiplication there, right? So that'll give us a total distance. We're going to go ahead and take that number, and we're going to square root it to get one side of a square. All right. So that's in millimeters. Assuming that I can do math today, which is not always a safe assumption. Google's really good at this thing. So if that'll give you some idea, that's one side of a sign that we could create if we gave one IPv6 address to each and every LED. And if you think that's 2 point something miles, you're missing the 1013. All right, that's scientific notation. It's huge. We could probably do a big camouflage over the entire galaxy. That'd be kind of cool. At least I think. I'd have to check with Jake, see how big the galaxy really is. All right, so it's a really, really big number. We'd probably have to strip mine a couple planets to be able to do that. I figured you guys were all probably going to be aware of how big it was, but it always is kind of helpful to kind of get the scale of it there. All right. So this really large address is going to look really, really nasty. I'm convinced that's also part of the reason why people haven't moved to IPv6. How many of you guys really want to type that in every time you do a ping? No, it's time consuming, it's annoying, and memorization is probably going to be slow.
You can shorten it.
Yes.
You get your own subnets. You create your own.
Yep, and you can do that too. Yep. This is a 128-bit number. That is actually IPv6.google.com. If you jump onto an IPv6 network and you try to go to Google, you'll have to go to IPv6.google.com. Why they decided they had to have a separate address, I'm not entirely sure. It's not a requirement. My site runs both. Runs IPv6 and IPv4. Google does strange things, so I'm sure they have a reason. It's a 128-bit number. There are 8 fields, 4 hex numbers in each field, and we call those hex tags. We use a colon separator to go ahead and identify the different fields. These records in the DNS system, again, as we've already mentioned, are tagged as quad A resource records. So if you're going to go do a lookup, you'll do something like dig-t quad A IPv6.google.com. And that really is their address. So this is a real number that you're seeing out in the real world. We do have some shortcuts. This is really just too big of a number for us to really work with easily. Sometime down the road after I've retired, someone will have to deal with this kind of number where they can't use some of these shortcuts. It doesn't have to be this way. 2 valuable shortcuts for us, and it's all about the zeros. So the zeros collapse, you live, and your life is actually a little bit easier. When you have a contiguous set of fields that are 0, you can collapse the colons. When you have a field that is prefixed with a 0, you can drop the 0. So notice that our 802 is no longer 0802. So that can make your life a lot easier. So double colon can only be used one time. Why can it only be used one time? Where do we expand this out? In this example address, we have 3 hex texts listed. There's 8 fields. So where do we put all those zeros? And this is the same problem the routers have. It's the same problem the hosts have. So what we do instead is we go ahead and ideally match the longest sequence of zeros. Any other fields we'll put a single 0 in. And it'll pad that out for us. So use your shorter field, right? Drop that leading 0. In the interest of best practice, use that colon. The only time that you shouldn't use the colon is if it is a single match. There's a single field that is all zeros. In that case, just use a 0. It's easier to read. It's going to be easier for you to kind of just look at. You're not going to sit there and be like, okay, so how many different fields do I currently have, and figure that out. Use your colons to cover the widest range of zeros where you can, if you happen to have equal sets, right? You will actually go ahead and want to use the one match first going left to right. All right. Use lowercase to avoid confusion, and that'll help out other people. All right. Addressing issues. If you really, really want to put in an IPv6 address instead of a host name, you can do that. Because of the use of the colons, you're going to use square braces, and then you can specify a port if you're going to do that. If you're not specifying a port, it's not a big deal. All right, multiple links, which one to choose? In fact, actually, it's possible to go ahead and have the same address but on different links. To specify which interface to use, we use % and then the interface name. And some tools like ping6 absolutely have to have that, depending upon the revision you're using.
Depends on the OS you're using. That brain fart, just lost the word. The syntax changes per operating system.
Yeah, I hadn't even thought about that. I live in a predominantly Linux world. So, yes, I'm horribly tainted that way, I'm afraid. So, there may be things that you'll find are a little bit different. By the way, did you guys notice that I was using the dead beef? Did anyone else notice the Facebook? They actually used Facebook during the first IPv6 day. So that was actually part of their address. All right. IPv6 Scopes. How many of you guys have heard about IPv6 Scopes at all? Yeah? So what the scopes are is something that you'll probably not have to deal with unless you're like Aaron and you're dealing with networking. The scopes allow you to go ahead and specify basically how far that broadcast is allowed to go, specifically with multicast. So you can go ahead and use scopes. The most common scopes that you'll see are going to be link local and global. 99.9% of everything you're going to see will be global. There are a few additional ones. How many of you guys have heard of site and site local scopes? Deprecated, taken back. So you don't have to worry about those. There is an administrative scope as well that you can use for a local scope. That is available. All right, so IPv6 scopes are not normally something you're going to set. It's something that the administrator of the network will have to deal with.
So is the goal scope is similar to that of NAT, although we're not natting addresses, we're containing network pools.
Yeah. Yeah. It's not. Yes, it is to provide that segregation. You can still provide your own subnetting, but it's to define the link when it comes to multicast addressing. Is there another question? No? Okay. Yeah, it really just allows you to basically say this multicast packet can go across this link or we're going to kill it. There are 3 types of addresses that are used. One is unicast, which is, again, 99.9% of everything you'll see. Unicast is used to identify a single interface. It can be run on multiple interfaces if the host supports it. The idea there is for load balancing. There's multicast address, which are actually, they're multicast address, but they follow the same format as unicast. They're actually out of the unicast block. And then there's anycast address. How many of you guys have used an anycast address today? How many of you guys know what an anycast address is? Yes, absolutely. So an anycast address has the same syntax as a unicast address. Your clients, according to the standard, should never have to know anything about that other network structure. It should never have to know if it's sending to an anycast address. It's just sending it to a unicast address. However, what an anycast address is that we have multiple unicast addresses out there, the same numbers, and the routers have determined which one is closer. Yeah. So, yes, the root DNS servers use it so they can provide connectivity based upon your region that you're providing the query from. Some of the special addresses that you're going to see. Loopback. It's even easier than 127.0.0.1, right? The unspecified address, used to indicate a default route. It also, when we are doing things such as the DAD protocol, is used as a source address. All right, so it's a special address that we use there. FE80s. So if you guys have seen an address like this, any interface that goes onto an IPv6 network will have a link local address. So FE80 is used to indicate that we're a link layer address.
That takes part of the MAC address by default?
Yes, by default it does, depending upon the host configuration. So Windows does not by default, as I understand it. It uses privacy extensions. You can enable privacy extensions in Linux as well. There's a kernel tunable for that. And depending upon the host you're using, depends upon where you configure that option. In this particular case, you'll notice this set of fields. So the first 64 bits of our 128-bit address is the network. We also refer to that as the prefix. This /64 that we haven't talked about yet, this is our prefix, and it indicates how much of the address is for the network. So 64 bits here describes the network. Last 64 bits is the interface, the EUI. Yes. Yep, absolutely. The prefix replaces the network mask. Okay. Multicast address, FFF00, and then we will have addresses for different multicasting groups. The multicast replaces network broadcasts. So if you're used to using a broadcast address, that goes out the window. We use multicast. All right, there are 2 special addresses that have been used for mapping IPv4 addresses into an IPv6 address. Right, so we have quad A, or not quad A, but quad zeros. Right, it's all zeros right up until the very last where you put in the IPv4 address. And we typically will see the FFF right before the last field. Where will you see that on a Linux system? You'll see it on what's called the SIT interface. How many of you guys have seen the SIT interface show up? No? A few of you? Yeah, so the SIT, SIT0, that's entire purpose in life is to receive incoming IPv4, well, I shouldn't say its entire purpose in life, but it's to receive incoming IPv4 connections, translate it to an IPv6 address for your clients, for your server software. That way it can go ahead and process that just like IPv6. So as we transition over to IPv6, it's already there. In theory, it makes it easier on the programmers. Okay, network versus host. We've already kind of talked about this. So the prefix is the network mask, right? This is, again, an example here. EUI 64 is for the host. Typically, it is possible to actually have a shorter host identifier than 64 bits. It's going to break autoconf. I don't recommend that you do it. Autoconf is there to make your life easier. However, it is possible, and you can statically assign those addresses. All right. In most cases, the last 64 bits will be the host. We just talked about that. We've already talked about the network mask. Notice the link. Note, you'll see the scope. You'll typically, again, see link for local link addresses, which start with the FE80. And you'll see global for other unicast addresses. How many addresses can you have assigned to a single interface? I haven't seen anything that says there's a limit. According to the RFCs, you're supposed to have multiple addresses. It's designed to have multiple addresses. And typically what you'll see is that same EUI 64 with different prefixes.
Does autoconf replace DHCP?
That was originally the idea. Originally, they wanted to go ahead and get rid of DHCP so you didn't have to have a standalone server managing address allocation. But a lot of people said, well, listen, I want to be able to go ahead and assign my own address. I want to go ahead and be able to manage these addresses. I don't want some random address that I don't necessarily know before it's created and onto the network. So DHCP v6 does exist. The last time I checked in Red Hat, they used to have a separate package in 5, DHCP v6. They've now merged it into a single package. It basically follows the same format you're used to with DHCP, and I know you're used to DHCP configuration. But there's a prefix option that you can set, just like there was subnet. And yeah, you can assign IPv6 addresses.
So because network broadcast is out the window, is it using multicast then for discovery?
With DHCP, I believe it is. I knew someone was going to ask me that, and I didn't get to it. All right. No, okay. I saw a movement back there, and it's like, okay, wait, what? Okay. Okay. So, yes, it does exist. Actually, you know what's really cool is the router when it does its advertisements, right? And when the host actually solicits to the router and goes, hey, tell me what my prefixes and so forth are. The router actually has a couple options based upon your configuration. One, it can go ahead and say, you're not getting anything from me, you got to go talk to DHCP. You can actually force the issue. It can also be configured to hand out prefixes, hand out configuration information, and tell the client to run the DHCP client. So you can actually run both a stateful and stateless setup. Yeah, I bet you were just dreading the fact that there was going to be no DHCP server, huh?
I was just curious.
Well, and you could. And the idea, part of the idea behind doing it this way, where we have a prefix, which is the network, and we have a host portion, is that if you were changing or renumbering your network, you're not renumbering the individual hosts. And you can have multiple prefixes, so you could actually have a transition phase. So you start handing out the new prefixes along with the old prefixes. You give a shorter lifetime on the old prefixes, and eventually they go out.
This might be beyond the scope, so let me know and we can talk about it afterwards. But how, if you got rid of DHCP v6 and just did autoconf, how would you, if you're doing a DNS system, how would you say that this server who did autoconf for its IPv6 address is really that server, if you're doing dynamic DNS based on, if it does its autoconf address.
How do you authenticate that it's
DNS update.
Yeah, so one of the things that I haven't mentioned here is you're familiar with IPSec, I assume. IPSec was actually formulated as part of the IPv6 standard and then backported to IPv4. If you want to enforce authentication, you can do that through IPSec. There's actually two different approaches to that one.
And that would be on the router level. So the router would be running up an IPSec server in radius auth or whatever auth type of thing.
Right. Well, so let me make sure it just occurred to me that I may have misunderstood your question. So let me clarify. Are you asking how can you guarantee that the EUI number that the system on the network is saying is mine is in fact for that host? Is that what you're asking?
Let's say I've got a rogue server out there
Mm-hmm.
attached to the network,
Mm-hmm.
and we already have that web server, the valid one on the network,
Mm-hmm.
and it has its own IPv6 address. And this rogue server has the same host name, and it's configured to do IPv6. And the router, it listens for the router advertisements, IPv6 router advertisement, grabs an IP off the router, and then submits that to your DNS server, say update the DNS entry.
Yeah.
with this IPv6 address.
Okay. So that's going to bring us to DAD, which is the duplicate address detection. It doesn't necessarily eliminate rogue, but what it does do is when an interface is brought up, it will look for duplicate addresses.
Duplicate addresses or duplicate host names?
Addresses. Addresses. It knows nothing about host names.
So how does it find duplicate address? You keep saying that broadcast is no more. How does it find peers?
Ooh, that's a great question. And it's coming up a little bit farther down. If you're talking about how does it know who else is on the same link, yeah. So there's the DAD protocol, which allows us to go ahead and look for duplicates, right? Other hosts with the same EUI, with the same prefix combination. And if there is, then guess what? We don't get to use it. And then there is the neighbor discovery protocol, right? Which we've got coming up a little bit later on. But the neighbor discovery protocol replaces ARP, and it's responsible for locating who else is on the link. The way that we can advertise to the entire link is through Multicast. There's a reserved address for that.
There technically isn't broadcast
Yeah.
by name, but there is multicast to all nodes.
Yep. Mm-hmm. Yeah. All right. Okay, so the prefix number. The prefix number, as I mentioned earlier, is really just there to indicate how much of the number is for the network. When we go to communicate to another host, you will not need to know the /64, right? You're not going to do ping and give it the address and do /64 or /56 or anything like that. When you manually configure an interface, you will be providing that prefix number. So it's important for you there. So it really is just replacing the net mask. And that's all it's really doing. Some of the more common prefixes that you may see, 128, where it's all one unique host. Everything is being used. /64 used to indicate the first half is used for the network, second half for the host. /47, really large network segments. /48, that's probably, if you call up your internet provider and you go, I'd like a home network, that's what they're supposed to give you.
28.
Yes.
That's a lot of addresses.
CenturyLink gives you a /48. It is. It's a really large amount of addresses. 48 was set aside for homes, for SOHOs. Some organizations will get multiple 48s instead of a 47. You're talking in the thousands of host combinations. I think it's 4,096 or so. Right now, IPv6 addresses are so plentiful. I'm going to give you a little story here. How many of you guys use Linode? No? Just me? Okay, a couple people. So Linode had, I love Linode. They've worked really, really well for me, but they've had a couple policies that seemed a little contradictory to me. One is, if I wanted to actually go ahead and get a second IP address, they would charge me $1 a month for it. Easy enough. And I'm thinking, that's pretty cheap. I can do that. It's not quite the deal I get with XMission, but it's still pretty good. And so I contacted them, and they're like, okay, so you have to prove the justification for it, because we're out of IP addresses. And I'm like, but you're charging me $1. How out of IP addresses are you? They're like, it doesn't matter. You have to go get an SSL cert, and it has to be signed by one of the trusted authorities, and our browser has to know about it by default. I'm like, well, that's going to be more than I want to spend. Never mind, because I'm cheap that way. Right? They rolled out IPv6, and I went, okay, I'm doing some maintenance. I want to get my IPv6 network up. And brought it up, AutoConf. It was wonderful. And I was kind of digging around their support documents and like, oh, if you want an IPv6 subnet, you can request one for free, and you'll get 4,096 hosts available. I'm like, well, wait a minute. You want to charge me $1 for one after I prove I need it, and you're going to give me 4,096 possible combinations for free. So it gives you a little contrast. Okay, so multicast. Multicast becomes really important in IPv6. How important does IPv6 become? It replaces broadcast. Once we have a link layer address, we actually use multicast to go ahead and solicit to the routers. We use the multicast to find out who else is on the link if we need to as well. When we occasionally send out information with a neighbor advertisement, we'll actually go ahead and send that to the all nodes in the link local. And it will contain updated information. So, as an example, let's say that we put in a new interface. Our old interface died, we brought up the spare. So the MAC address has changed. So the EUI number, that last 64 bits, has been recalculated. It's the same prefix. It will actually advertise that change for us. If we still have the old interface in, we can actually keep that deprecated address long enough for existing communication. That actually becomes more important when you talk about privacy extensions. All right. A couple special multicast addresses. FF01 for all nodes, that's interface local. FF02, all nodes link local. FF01::2 for all routers, interface local, and FF02::1 for all your routers on the local link. So if we need to solicit information from the router, we want to find out our prefixes, and we don't want to wait for its broadcast to the all nodes, we go ahead and send the query to that address. All right, solicited node, anytime we set up AutoConf, it is required that your node set up this address. The last 24 bits, these X's, will be replaced with the last bit of your MAC address, right? Well, I shouldn't say your MAC address, your EUI. ICMP v6 becomes more important. In fact, it adds a couple things. Router solicitation, router advertisement, neighbor solicitation, neighbor advertisement, and redirect. When I set up my Linode system, first thing I noticed was that I wasn't getting any traffic. I wasn't even getting my address. And I was very disappointed by this. And I sat there, I was really frustrated. And the reason why, it turns out, was my own silly fault. When I set up IPv6, being a reasonably knowledgeable person, I said, I want a firewall on this thing. Because I'm going to be able to communicate with everyone else on the internet. They're going to be able to communicate with me. I know applications are binding to IPv6. I should do this. And so I copied over my existing IP tables rules for IPv4 and modified them as appropriate. I block a lot of ICMP stuff in IPv4. I've changed my stance on that since I did this. So what happened? Well, as I brought the interface up, my system attempts to communicate to the router solicitation, and it uses ICMP-v6. And my firewall very diligently said, not happening. We're not going to get any responses. Which means the router's not able to advertise its configuration, which means I don't get my prefixes. Which means I'm dead in the water. Neighbor solicitation and neighbor advertisement. If we want to find out who's on the local host, we've been given an IP address, and we need to communicate with them, and we need to get that link layer address, we send a neighbor solicitation to that host. They are supposed to respond with a neighbor advertisement with their link layer address. If their link layer address changes, they're supposed to broadcast a neighbor advertisement. Again, using that multicast address we saw earlier. And finally, there's redirects. If we try to communicate with a host and the router for some reason knows of a better path, it can use the redirect to point us to the next hop. Don't block all your ICMP traffic, you're going to break things. It's probably not the best suggestion to just block ICMP in the first place. Speaking of hops, every packet that goes out has a hop count, maximum 255. And every time that it is touched, the router is supposed to decrement it. Every single time. If it doesn't reach its host in time, it sends it back. Right? Why do I mention that here? Because when we are trying to get the prefixes, we send an ICMP v6 packet with a 255 host count, and if it's anything less, the router drops it. And does this intentionally, so someone can't try to broadcast that packet and get the prefix and configuration information. All right, let's talk about Dad. My dad was kind of an interesting fellow. Totally different than this dad, of course. Well, that joke did not go over at all, did it? All right, it sounded so much better last night at 2 in the morning. Okay, so Dad, duplicate address detection. When we bring an interface up, we have to identify, does someone else already have this address? And Dad is the method of doing this. If we go ahead and assign an additional address, it is Dad that is responsible for doing this and identifying if that's valid. What happens? Well, if it is not one of our privacy addresses, we'll flag an error back to the kernel, and we stop. Privacy extensions use a randomly generated address. So what happens if we happen to pick one someone else is using at the moment? Well, Dad will go ahead and say, yeah, we can't use this. And depending upon the host, we will regenerate an address and try it again. So if there is a conflict, it will try it again. By the way, the previous scenario where we talk about assigning address manually depends upon the host configuration as to what it does. Other operating systems may have you specify an alternative address. And then they may try additional addresses and rerun Dad. So, overview of how Dad works. When an interface gets an address, before it can use the address, it sets it as a tentative. It doesn't actually get to use this. It will then go ahead and send a neighbor solicitation to the address that it's been assigned. What happens if we send this off onto the link and someone responds to it? Someone else already got it, right? So we go ahead and we go, oh, well, we can't use that. What happens if we send that out and we don't get a response? Yeah, we're all happy. Does it matter if it's the same address for a different host on a different link? No. That doesn't matter to us because the prefixes should be different, or we may be in any cast address. All right, if we do not get a response, we get to go ahead and use that address, at which point the tentative address then becomes a preferred address. All right. We get to talk about Neighbor Discovery Protocol. Yay! We've now gotten an address that is unique. I'm really happy about that. Okay. The Neighbor Discovery Protocol actually replaces ARP. Goodbye, ARP. It was nice knowing you. How many of you guys have used the IP tool? Yeah? You use it all the time? Anyone else? Okay. Right. So the IP tool has an IPNA option, which is used to show the neighbor cache. And it also handles ARP. It's one of the reasons why you should be transitioning over to IP if you're using Linux. What happens is the Neighbor Discovery Protocol is responsible for actually taking your IP address and translating it to a link layer address and maintaining that table, much like ARP did. When we do that, we use the neighbor solicitation and neighbor advertisement to do that. If we get a response, we go ahead and build our table, and we hold on to that information. And as long as we're able to keep sending packets, there's a reachable timer. And every time we get a response, we're able to send and get a response, we reset the timer. Depending upon your host, depends upon what do we do with the table after an expiration period or after a certain amount of size has been reached. It's up to the host to determine cache clearing. What happens if we happen to get that neighbor advertisement I mentioned earlier where we have a different EUI number? Someone has gone in, maybe they've done the privacy extensions, a new number has been generated. They send out an unsolicited neighbor advertisement. They send it to the Multicast group. They say, here's my new information. Well, we don't go in and change the table. Instead, what we do is we mark the entry as stale, and the next time we go to establish communication, we reprobe that. We will get that information again. What happens if we can't get to the host? So the neighbor and reachable detection protocol is used to determine if we can no longer communicate with a hop, the next hop. It can use upper level hints. Hey, we still have TCP traffic going on. Okay, we're good. Not necessarily wholly reliable, but it is useful. If we don't have those upper level hints, we can go ahead and send an ICMP packet, a solicitation, see if we can get a response. If we cannot, it removes the entries from the cache for us. All right. Neighbor and destination cache are actually two different caches. Yeah, Aaron.
I was just thinking about the global internet routing table. We're at, what, 4,000 entries right now on IPv4.
Mm-hmm.
What's this going to do for our routing table for IPv6?
Oh, as far as the neighbor and reachable protocol going in and butchering things?
Well,
It's only for the local link. Yeah. I'm sorry, I should have clarified that. Yeah, it's only for the local link. We do maintain two different caches. We maintain a neighbor cache, which is for local link. And we maintain a destination cache, which is effectively the routing table. And so we maintain those. So entries are created as connections are created. We update that reachable timer as traffic continues on. And again, if we get an unsolicited neighbor advertisement, we'll flag it as stale. So that way we're not constantly rebroadcasting and finding out who's next to us. To view the neighbor cache in Linux, you're going to use IP neighbor show. To manipulate it, it's also IP neighbor. I'm not sure what it would be in other tools. I'm sorry. Based upon the amount of Macs, I should probably go invest in a Mac and learn that one too, because that seems to be pretty popular. All right. The router is really, really important for us. As you've probably picked up, the router is kind of a linchpin here, right? It does a lot of work for us. In order to be considered a router, by the way, it does have to have IP forwarding enabled. According to the RFCs, it's not allowed to respond to a router solicitation or a router advertisement if it doesn't have IP forwarding on. All right, it uses ICMPv6 to go ahead and occasionally broadcast router advertisements and to respond to router solicitations, and if there is a redirect that needs to occur, to do the redirects. What are router advertisements? Something I can't say at the moment. They're periodically sent by the router. They basically contain the prefix information as well as configurations for that local network, such as the MTU. What's the maximum transmissible unit we're going to consider here? What's the default router? And whether or not we're going to require management through DHCP. If we have multiple routers, advertisements going on from different sources, we use a union of the information. The most recently received takes precedence. Something that is very interesting about the way the RFCs are written, if we receive an advertisement that would completely eradicate what we've learned, it's ignored. So I'm not entirely sure how that is going to play out, but that's the way I read it. Okay, router solicitation. Again, the router occasionally advertises information. These are the prefixes I know about. This is the default route, that kind of good stuff. If it does it about every 5 minutes or so roughly. It's got a random time. If we bring a client on and they go, I haven't heard anything, I need to find out this information, it sends a solicitation to the all routers multicast address, and that can initiate a router advertisement. As far as that goes, according to the RFCs, there's also supposed to be a random delay for sending out those solicitations. Why? You lost power everywhere. Everything's coming back up.
Oh, right. You don't want to slam the router.
Right. We do provide in Linux, and I'm sure it's been ported to other platforms, the router advertisement daemon if you don't want to go buy a nice fancy Cisco switch. I hear they're really cool. I can never afford one, though, so I don't get one. The router advertisement daemon only works if you are using a 64-bit EUI. It advertises your prefixes. It can advertise your default route and a selection of some of the different options. It's a very simple tool. It works pretty well. It's not meant to replace DHCP. If you really want to assign those addresses, that's not what it does. It hands out prefixes. Stateless configuration. This is the really cool Slack stuff. I like calling it Slack because A, that's the name, and B, it reminds me of Slackware, and I like to Slack. So it's all kind of cool that way. Typically what we'll do is we'll use the 48-bit MAC address. We'll go ahead and generate the 64-bit EUI, and then we'll go ahead and basically apply the prefixes. Why would it not work? Well, for one, we've blocked ICMPv6. Right, that'll break it. Or we've decided we want to go ahead and try a larger network and subnet beyond that 64-bit. That is, when we talk about Linux, that's the default. It will automatically do that if you enable IPv6. Oh, good heavens. I missed the time. We're almost up to an hour. Stateful configuration. Basically, any time that you are supplying the address, it is stateful configuration. And as I mentioned, we're not going to talk about DHCP configuration. It's basically the same DHCP configuration you've seen. Host address is just going to have an IPv6 address instead. You can manually assign it in however the host OS wants to do it. It can coexist with stateless. You can have multiple addresses. They can be stateful and stateless. That is perfectly fine. And the interface identifier can actually be smaller than 64 bits, but again, that potentially can cause some headaches. Privacy extensions. Because some people are concerned that using a MAC address will help identify a particular user, really a node, but that generally translates to a user through data mining, privacy extensions were proposed where they use randomly generated digits. They actually use MD5 for the hash. It's a requirement of IPv6 for IPSec, so they already had it there. Usually this is going to be generated when the interface is activated, but the RFC does call for random changes. So it can change over time. Because it does that, it's really bad for servers.
I can just think of like Tor.
5 minutes.
5 minutes? Okay. Yes. Yeah, it could be really slick that way. And actually, areas where you have governments that want to suppress people and all that good stuff would be of high interest in doing that. I'm just going to remind you guys that if you do stupid things, you will face consequences, almost inevitably. There was an administrator that got fired. He left a back door. He decided he'd be really, really clever. So you know where he decided to get his internet access so no one could track him? McDonald's. You know what McDonald's has along with free Wi-Fi? Cameras. It didn't take them very long. So, all right, to enable privacy extensions in Linux, there is a kernel tunable that you can set, net.ipv6.conf $device.use temp address. The $device being whatever the device is. Check your local host configuration file, whatever OS you're using, to see how it's done. In Red Hat 6, there's a specific option for the privacy. All right, configuring IPv6 in Linux. IPv6 is its own stack, so it does have its own firewall rules. It's done through IPsec tables. The syntax is still the same. It is still stateless and stateful capable, so you can go ahead and inspect packets for your protocols. Those haven't changed. It does use IP for features that are not supported through ifconfig. And in Red Hat 6, I don't know if any of you guys have seen this, to give you an idea as to where Red Hat feels about this, if you type man ifconfig in Red Hat 6, it says it's deprecated, obsoleted, and will be removed. It's right there in the first page. So everyone should be going to IP according to Red Hat. All right, better support for tunnels. You can actually set up tunnels there. Ifconfig has been deprecated. It supports the use of the neighbor discovery protocol, and it's still non-persistent. Isn't that great? Based upon RHEL 6, I told you guys I'll tell you how to configure GoOSe and Red Hat and CentOS. You know, they're all based off of Red Hat, which is based off of Fedora ultimately. How do you configure it? Etsy sysconfig network has a couple IPv6 options, including IPv6 forwarding, which turns you into a router, no longer a host. Anytime you do forwarding, you're a router, not a host. It's just the way it is. IPv6 init, to enable it. You can also do it for individual interfaces as well. And that's done in Etsy sysconfig network -scripts if cfg -whatever. This is a selection of the options. Documentation is here. Right? User share doc init scripts. And it's sysconfig.txt. The graphical way. Network manager is the preferred method of managing your networks in Red Hat 6, so nm-connection-editor, which does not support privacy for some odd reason. Huh? Kind of sucks, doesn't it? In SUSE, you have to load the IPv6 module, but it does come with it. And of course, you use YAST. Anyone use SUSE? Oh, wow. Okay, I figured there'd be more. I figured I was in Provo and all, so. Oh, maybe. You don't actually have to use YAST. There is a configuration file. Etsy sysconfig network, ifconfig, ETH ID, and then the MAC address. Documentation is in user share doc packages sysconfig. All right, what is this SIT interface? And you can create SIT interfaces. It's the simple internet transition tool. It translates IPv4 into IPv6 addresses. Some daemons may force you to choose one or the other, in which case I would suggest IPv6 because you can have it bound to the SIT interface, which will translate IPv4 into IPv6, and the return packet gets fixed for you. It's also used for setting up tunnels. Some daemons already are binding to that SIT interface for IPv6. If you say all interfaces, like Apache's HTTPD, it automatically binds to the IPv6 only and uses SIT to pick up IPv4 traffic. Tools that you can use, obviously IP, I've mentioned a few times. Ping 6, most of your IP6 tables and traceroute 6 got the theme. Tack on a 6 someplace in the name, typically, or use a TAC 6. And if you want to play with IPv6 right now, talk to your ISP. They may have it, or you can find a tunnel broker. I set up with HE.net. They seem to be doing really well. One of the things I like about them is a simple web interface, and they have certification as well. So they've got tutorials, they'll tell you how to get through it, and the chance to verify your system setup with them. All right. Questions? All right. No questions? Okay, well, if you got questions, you can ask me. As it says in the bio, feel free to say hello anytime you want.
If you're just creating like a local test network that doesn't need to be routed, do you have to have a router with IPv6?
Nope, you do not. In fact, you'll probably just use the link local address, the FE80 address, because that automatically comes up.
And the autoconfig will still work with that?
Yeah, it's automatically, that address is automatically configured unless you do privacy extensions. In which case, it's still auto-configured, but the numbers change. Yeah. Okay. Thank you, guys. You guys are my alpha betas tomorrow.